Hello, this is the second video on geometric sequences. We're having a look at another couple of examples. So example 10. We've been told that we've got three terms, the first three terms in a geometric sequence, 3, x and x plus 6. And we've been asked to find possible values of x and the 10th term in the sequence. So first of all, let's write down what we know. So we know that u1 is equal to 3, u2 is equal to x, and u3, the third term in the sequence, is equal to x plus 6. Well, we know there's a geometric sequence and we've got a common ratio between those terms. So x must be a common ratio bigger than 3, x plus 6 must be the same ratio bigger than x. So if I take my second term and divide it by my first term, it's going to give me the same common ratio as if I take the third term and I divide it by the second term in the sequence. So what have we got? We've got u2 is equal to x. If I divide that by u1, which is 3, that's going to be the same as the third term, which is x plus 6, divided by u2, which is x. Well, we can rearrange that. So we multiply through by x and 3. We're going to get x squared is equal to 3 lots of x plus 6. X squared is equal to 3x plus 18, x squared minus 3x minus 18 is equal to 0. I reckon I ought to be able to factorise that. Let's give it a go. We've got x minus 6 and x plus 3. So minus 18, minus 3, yep, that's looking good. I have been told that all of the terms in the sequence have got positive values. So all the terms in the sequence, all positive values. So if x is one of the terms in my sequence, x is going to have to be positive. So I'm not interested in the negative 3 solution. X is going to be equal to 6 as x is greater than 0. Second part of the question, so that's part A finished. Second part of the question, we're looking to find the 10th value of the value of the 10th term in the sequence. So part B, I'm looking for u10. Well, what sequence have we got? I haven't actually looked at that. We've worked out that the first term is 3, and the second term is 6, which we know is 6. Let's write that down. The third term is x plus 6. X is 6, and that's going to be 12. So we've got a geometric sequence. The first term is 3, and we're doubling up each time, so my common ratio is equal to 2. So my nth term expression, un is equal to a, which is 3, times my common ratio 2, multiplied by n to the minus 1. And we're looking for the 10th term in the sequence, so u10. u10 is equal to 3 times 2 to the power of 10 minus 1 to the power 9. So 3 times 2 to the 9. Let's go for the calculator. 3 times 2 to the power 9 is equal to 1536. 1536 for U10. Okay, let's have a look at one final example, number 11. This time we've been given another geometric sequence. Starts 3, 6, 12, 24. Looks a bit familiar. And we're looking for the first term to exceed 1,000,000. Okay, so let's write down what we know. We know that a is equal to 3, first term in the sequence, and we're doubling up each time. So my common ratio is equal to 2. And we're looking for the nth term that's going to be greater than 1,000,000. So let's write down the expression for the nth term. It's equal to a times r to the n minus 1. We know what a is, it's equal to 3. R value is equal to 2, and I'm going to raise that to the power of n minus 1. And I'm going to compare that, I'm going to compare un equal to 1,000,000. I'm going to try and find the value where it's exactly equal to 1,000,000, and then I can try and find the next term on. So un was equal to this thing, so 3 times 2 to the n minus 1 is going to be equal to 1,000,000. And I'm trying to solve for the value of n. I'm going to need to use some logs. So if I log both sides, I'm going to get log 3 plus log of 2 to the n minus 1 is going to give me log of, get my zeros right, log of 1,000,000. So log of 2 to the n minus 1, so that's n minus 1 lots of log 2, and that's going to be equal to log of 1,000,000 minus log 3. So we're almost there. If we divide by log 2, we've got n minus 1 is equal to log of 1,000,000 minus log 3, all divided by log 2. Let's pop that into the calculator. So log of 1,000,000, 2, 3, 4, 5, 6, minus log 3 gives me 12.71. If I divide that by log 2, that's going to give me 18.34. So n minus 1 is equal to 18.35. N is going to be equal to 19.35. So the 19.35 fifth term, if I could actually get at it, would be equal to the value of 1,000,000. So the first term to exceed 1,000,000 is going to be when n is equal to 20th. So the 20th term is going to be the first one to exceed 1,000,000. At this stage, it's probably worth double checking what the value of the 19th term is, just to double check that it is less than 1,000,000. So let's have a look and see what it is. So U19 is going to be equal to 3 times 2 to the n minus 1. So 19 take away 1 to the power of 18. Let's pop that in the calculator and see what we get. So 3 times 2 to the power of 18 is equal to 786,432. So it's less than 1,000,000. I also know that when I multiply 700,000 by 2, that 20th term is going to take me over the 1,000,000. So that double check, so that was 786,000 and a bit of change, less than 1,000,000. That 20th term is going to be the first term over 1,000,000. Okay, thank you.